Okay, so this section's a little long, so see how it goes. Hopefully, I think we have time for just this one section today. We'll most likely be here the entire time. So here's the first double angle. It's sine 2 theta. Sine 2 theta is equal to 2 sine cosine. Number 2 is cosine 2 theta. This one has 3 different forms, so you can use either one, doesn't matter. Sometimes using a specific one is easier than the other. So cosine 2 theta is equal to these 3. So use either one, doesn't matter. Although if the question asks for put it in cosine, then you should use the third one. If they say they want it only in sine, use the middle one. Okay. Tangent is equal to 2 tan theta over 1 minus tan squared. Let me give you the half angle. Sine of theta over 2 is equal to plus or minus the square root 1 minus cosine theta over 2. So like last time, you're gonna have to figure out that you're gonna choose the plus or the minus, and that's gonna depend on the location of the half angle, not the theta. Okay. And then you're going to have to figure out if this cosine is also positive or negative, depending on the quadrant. So these will be a little more, yeah, a few things to worry about, I guess. Tangent, theta over 2. This tan has 3 forms as well. Has the square root form. You guys cool on the top? Okay. I'm assuming everyone got the top part. So let me know if you didn't. The power reducing, you can, whenever you have a square or any even power, you can apply these multiple times. So you can go from a square to a single power. But each time you do that, this angle is going to double. Okay, the last formula for today, and then we'll start. No, wait a bit. Okay, so you guys cool on this page? Any issues on my handwriting? Okay, we're going to keep referring to this page. Also, as you build your formula sheet, I try to put these at the beginning of the lecture, so just add it to your sheet. Okay, that way you'll be ready for your exam. Okay. Alrighty. The first one's pretty easy. First example. At least I hope so. They're using a double angle to find the exact value given that tangent of theta and they're actually going to tell you that theta is in quadrant 2. Find sine theta, sine of 2 theta, cosine 2 theta, tangent 2 theta. So before you do anything, find the trig functions. And if you looked at all these formulas, right? Here. For the double angles, we're going to need sine and cosine. So we got to find both, especially for sine. Technically, you can get away with finding only one of them for the cosine. But since we're going to have to do sine as well, might as well find everything. So tangent is negative. But although they told us a quadrant 2 is x and y negative. Which one is negative? Yeah, x is negative in quadrant 2. And we're given tangent, so that's going to be 3, 4. So x will be here. This is the magic triangle, 3, 4, 5. So you don't have to solve for it, but if you do, it's going to be a 5. And either way, I don't care how you do it. Find sine. That'll be 3 over 5. Cosine adjacent over hypotenuse. Is there any questions on this step? Is that okay? Right, once you have that, you can just solve ABC. It's just straight up using a formula, nothing crazy. So part A is literally apply formula. Sine of 2 theta is equal to 2 sine cosine. Plug in what we just found, and that's it. So 2 sine cosine. 2, 3, 4. So 2 times 3 is 6 times -4. It's -24, right? Over 25. 5 times 5. Remember, that's all 2 over 1. So you're only going to multiply the top. Any questions on part A? Is that okay? So double angle for cosine, you can use any of those three. I'm choosing just to use the first one for no reason. Doesn't matter. Plug that in, you'll get cosine squared minus sine squared, which is 16/25 minus 9/25, right? 16 minus 9, is that 7, right? All right. Oh, double check me. Especially okay. Is part B okay? It's not too bad. All right. I see. C tangent 2 theta. So we said that that was equal to 2 tan over 1 minus tan squared. Let's see, where's a nice place to plug this in? I guess over here. 2 times tangent, which is up here, that was given to us. So plug that in right there. -3/4 times, or over, sorry. 1 minus that same garbage squared. So technically that is your answer, but we have to simplify. That's basically your pre-cal step, that first line. 2 times this garbage is 2 times -3/4. That'll be 3 halves, right? 1 minus 3/4 squared, that's going to be a 9/16. Okay. 1 minus 9/16. 7/16. That'll be -3 halves times 16 over 7. So this will reduce to 8. 3 times 8. Okay, there it is. All right, that was annoying. There it is. Any questions on the fraction step? That okay? Forgive me if I'm more tired than usual. Didn't get much sleep. But so far, it's not too bad, right? Straightforward. Just using the formula only, and the beginning was stuff we did from test one. I'm hoping that the first few problems are easy, and if they're not, please let me know. Okay. Do something different. It's cool in this example, right? Right, number 2, there's a few of these type. It says using the double angle. Double angle formula for cosine. The instructions will be put cosine 6x in terms of cosine 3x. Okay, yeah. Do you guys agree that 2 times 3 is 6, right? So this is the double angle, so you can apply the double angle and get to a cosine that just has 3x instead of a 6x. So right here, well, I guess let's try an extra step so it makes more sense. Let theta equal 3x. That would mean that we have cosine 2 theta. So apply your formula. They wanted in terms of cosine, so use this bottom one. Okay, they didn't say they wanted sine. They use this guy. Right? So that would be 2 cosine theta, 2 cosine squared theta minus 1. But make sure you change it back, because I made this up. That's all I want you to do is apply the double angle once, but use the specific one they're talking about. Is that clear? Not much to do here.
Give another value for cosine 7.
7, you probably can't do the double. You could do a sum and difference from 7 to 2. You could break it up into like cosine 4 plus 3, and then separate them. And then those even ones you could do double. If that was required, I guess. Depends on the question, right? But you could do that, but not double. So and you could do it in fractions, I guess, but it'd be kind of weird. Okay. Example 3, we're gonna do an actual proof type. Do the following. 1 plus sine 2 theta is equal to sine theta plus cosine theta. I'm going to choose the right because it looks like when I multiply it out, I'm going to get a bunch of terms. So it looks more complex. I think the left would probably work. But it would be complicated. About the same, honestly. It's about the same. This time doesn't matter. But I'm going to choose this guy. Right-hand side. So if you follow that out, if you multiply it twice, you're going to get three terms. You're going to get sine squared plus 2 sine cosine plus cosine squared. If you do all the multiplication, you'll end up with these 3 terms. I skipped the times. That okay? So at this point, you want to get to here. So if you see the sine squared and cosine squared, that should be very familiar, right? What does this turn into? Yeah, it's going to be a 1. So if I rewrite it just to make it more obvious, this right here is 1 by Pythagorean, right? It's the first Pythagorean formula we talked about. What is this? That was the first formula we wrote today. Yeah, this is the double angle, right? So we're going to get 1 plus sine 2 theta, which is what we wanted to show. This is indeed equal to each other. Are there any questions on the steps? Some can be, I'm sure if you noticed on the homework, right? Some are super easy and some are just insane or just strange. It just depends. Sometimes there's a shortcut or that you don't see until later. All right. No, wait a sec. Okay, the next one's gonna be a hard proof. You guys okay on this page? Verify the following. Prove that tangent of 2 theta is equal to 2 over cotan minus tan. I don't know what's easier, which side to start on. I'm gonna choose tangent 2 theta just because we just got a bunch of double angle formulas, so maybe that'll work. And if you look at your formula sheet that we just wrote down, tan 2 theta turns into a fraction, right? So maybe that's the right step. I don't know. That's my line of thought. It looks like I'm on my way to this. It even has a 2 in it, right? Okay, so I'm going to start right here. Tan 2 theta, starting on the left-hand side. Double angle formula says this is equal to 2 tan theta over 1 minus tan squared by the double angle. Okay. All right. Now I notice, hey, you guys remember, right? At this point, I hope that this is equal to 1 over cotan. And cotan is equal to 1 over tan. So if you multiply tangent and cotangent, they should cancel, right? So I'm thinking I should multiply the top and bottom by cotangent. That'll cancel this one. Because notice there's no tan here. Also, there's a cotan down there. So I'm thinking if I introduce cotan, that might get me to, or introduce it here, it might get me there. That's the thought process. I'm just trying stuff. Is that the best way? I don't know. It might be another way that I don't see. So I'm going to purposely multiply by cotangent over cotangent. You can always multiply by any form of 1 except 0 over 0. So you can always choose whatever you want here to do your manipulation. So you're going to get 2 tan cotan over, distribute that cotan. Oh, thanks. You're going to get, oops, messed that up. Cotangent minus tangent squared theta times cotangent theta. You guys see the distribution? This is clear from here to here? Let me know if it's not.
There's two at the bottom.
Yeah, because you're gonna have to distribute it both. So picture like a parentheses here, right? So at this point, I'll show one extra step. Here, let me show the step for you. Two extra steps. Parentheses, right? So over here, we'll get right to that line I erased. Now I'll start canceling tangents. Tan times cotan. It's gonna cancel. Do you agree that the top will be a single 2? All right, because cotan is this, so is that clear? Are they canceled, or do you need an extra step? Okay.
So tangent by cancels it.
Yeah. I'll show one more extra step just in case. So I don't trust you guys. So cotan is 1 over 10. So clearly they cancel, right? That make more sense? So that means that one of these will be canceled. So these are gone, and one of these are gone. But finally, we're at 2 cotan minus 10. That's what we wanted to show, right? And any questions on the steps? Make a little note here. Multiply by cotan to try and cancel terms. That was the thinking behind it. Okay. I was trying to cancel that term up top. Yeah.
The return like well the sine times cosecant that would cancel like sine as well or
Yeah, cosine times secant would, and you said sine and cosecant, right? Yeah,
so that would cancel all of this.
it'd be the same thing, just like this. It's like 4 times 1/4. Right? It's gonna cancel. These are hard to they're hard to teach because a lot of the understanding comes from experience, and I can't put experience in your brain, right? You have to practice. So when you're practicing these, and if you're struggling, just remember you got to keep trying something until it works, right? Just so if you go off the rails and it doesn't make any sense, try something different. Okay, just keep trying something. But it's all going to be based off your algebra skills. So if your algebra skills are weak, then it's going to be even harder. So careful. Anyway, you guys cool on number 4? All right. You ready?
Yeah.
Yeah, no rush. No rush. Okay. Let's move on to something else. So this one we'll have different types of problems. Some will be, problem solving. Some will be proof type. Some will be just strange. Write an equivalent expression not containing powers greater than 1. So basically going to give you a higher power, and you got to reduce it until there's nothing but linear powers of 1. So here's the question. Reduce this guy. Now this technique doesn't become useful until calculus 2. So if you're not going that far, then oh well. Too bad. But we still gotta learn the technique. You agree that cosine squared squared is the same as a fourth? Right? You square it twice, it's a fourth power. Same thing. So I'm rewriting the problem because I have a formula for a square. See where I'm going with it? So right here, apply the squared formula, which is 1 plus cosine 2x over 2 squared. So this is from one of the last formulas we wrote down. It's like number 7 or 8 or something. Okay. But once you get here, you're gonna have to multiply and you're gonna get another square. So you do it again to that particular square. So FOIL the top. Let me show an extra step here in case your algebra bothers you. Square the top and bottom. If you square the top, you will get a trinomial. I'm gonna plot the 1/4 because it looks kind of annoying, right? Let's not deal with it. So right here, apply the formula again. But notice whenever you apply it, it doubles the angle, right? So if I do it again, right here, what do you think the angle will become? If you double it twice, what would then the answer become? See what I'm saying? So we're gonna do it to this guy. That'll be 1 plus cosine of 2 times whatever's in here. So if it was a 3, you'd have 2 times 3. If it's a 2, it's 2 times 2. Is that clear? Is that weird? So I applied it on this piece right here, the half.
So you get 2 cos 2x counter.
Oh, and you multiply this guy here. You multiply it twice, you're gonna get this middle term.
Why do you?
This too?
Yeah.
Oh, so I skipped an algebra step. Show the 4th for you. Those two. If you squared, you agree that that's the same as multiplying this twice, right? Same thing. So 1 times 1. 1 times cosine. Cosine times 1. Cosine times cosine. This is the step I did not show. So you're going to get 2 of them. So that's where the 2 right here came from. So we got to deal. Then we got to deal with that square. From here. Okay. So this square is transformed with the formula one more time. And technically the pre-cal step is done. The rest is just algebra. Any questions on any other steps here? Right, let's do some algebra then, I guess. So the 4th is on everything, so just go ahead and multiply. So give you 1/4 plus 2/4 plus, I'm gonna pull that half out. That'll be an 1/8, right? I don't know if this is better or not. Maybe it's worse. So I had a half on there, now I have an 1/8 because I multiplied the 4th. All right. Just combine them to get the same denominator. This will become 2/8 plus 4/8 plus 1/8 plus cosine 4x 8ths. Let's combine them all together and you'll be done. 2 plus 1 is a 3. So that's cool, I guess. 3 plus 4 cosine plus cosine 4x. Oh, that's 20. Okay. Any of the fraction steps bothering you? Is it okay? This would be the back of the book answer, the one that's always perfect. You ever see those? It never looks like your answer, but you're technically right still. So don't let those answers throw you off. Your work might still be great. Maybe you stop over here, right? Or maybe you stop here. That's mostly right. Don't doubt yourself. This is just the polished uh, final product. Requires algebra skills. Yep.
Go back to the where you got the 1 point. I understand.
1/4 was because I had to square the top. So that we showed that over there, right? You square the bottom, you get a 4th. So I factor the 4th out of everything, put it in front. Just so it wouldn't be in the way. That's over here, I'm gonna ignore it. And then I applied the formula one more time here. And I left the 4th there, and then I realized, all right, well now I gotta bring it in. Once you bring it in, 1/4 times 1, 1/4 times 2, 1/4 times a half, right? Technically there's a half on there. So I changed it to an 1/8, just to skip a small step. So is that weird? Yeah. So if you want, you can write this here. Maybe this is better. You write it that way if you want. But then the 4 times a half is an 8. That should be 4, right? Yeah, there we go. Sorry about that.
At the very beginning, I was going to space into X and divided by 2.
Oh, it's just from the formula. Look on the first page, numbers 8, I think it is. It should be, oops, I didn't write it, did I? Should be over 2. Glad you mentioned it. I don't want to give you fake formulas. That would be a problem. Should be a 2 underneath both are reducing. Okay. The only one that doesn't have a 2 is a tangent, because if you divide them, you notice you're going to cancel the 2's. But anyway, any other question number 5? Let's do a half angle problem, because those are more complicated. Find the exact value given tangent theta equal to 8/15. And theta is in quadrant 3. Find sine theta over 2, cosine theta over 2, tangent theta over 2. So at quadrant 3, everything is, cosine is what? Is it positive or negative? Yeah, it's gonna be negative. Same for sine, right? So they're both negative. So the information they gave us was that theta, quadrant 3 means. You go from 180 to 270, right? Look at your circle. Quadrant 3, the beginning is 180, ending is 270. Look at that section, that slice. Now, if that's where theta is in quadrant 3. Where is theta over 2? Where's half that angle? So in order to find it, you got to do this. Divide everything by 2. So where is theta over 2? Yeah, that's going to be quadrant 2, right? So this is quadrant 3. This means quadrant 2. So they told us quadrant 3, which means this. Okay. They also gave us a tangent. So tangent is equal to -8, -15, because x and y are negative in quadrant 3. So for theta, these are negative. Pythagorean is going to give you a 17 for hypotenuse. Okay, so now answer the question, what is sine theta over 2? So part A, sine theta over 2 is equal to plus or minus square root of 1 minus cosine theta over 2. Okay. So you're going to choose, depending on where theta over 2 is, that's when you choose the plus or minus. So you have to pay attention to where is the half angle. Is sine negative here? No. So you pick the plus. And we put a negative on the x value, so that means this cosine will be -2. Okay. So I'm gonna go ahead and write these down. Sine theta is -8/17. Cosine theta is -15/17. And they gave us tangent, right? So I'll just write them down there for now. Okay, so plug in this garbage. 1 minus cosine. That's technically the pre-count answer. The next step is algebra to clean it up. You see why we picked a positive square root? Do you see why that cosine is negative? Those are the concepts you need to remember so you don't pick the wrong one on a test. The wrong sign. Okay. So 1 minus 15/17, that's a double negative. So that's the same as 1 plus 15/17, which is the same as 17 plus 15, that's 32, right? Divide by 2, that'll reduce the 32 to 16. Or flip it over and multiply. This would become, I'm going to skip that step, 16, yeah, over 17, which will be 4 over root 17. Make some space here. you want to rationalize, you'll get this. Any questions on part A? Is that okay? Let's see if I have enough space for B. Still got time, right? Yeah, we're good. Cosine theta over 2. That's going to be plus or minus the square root of 1 plus cosine over 2, right? Okay. Theta over 2 we said is in quadrant 2, right? Is cosine negative in quadrant 2. So we pick the minus. So we're going to get negative square root 1 minus 15/17 over 2, which will be negative should be minus 2. Let me show the step this time. You get the common denominator, it'd be 17 minus 15. Which will be negative 2 over 17, but the 2's will cancel the next step. Anyway. All right, so let's go over this for time. To choose the negative, because of the quadrant of theta over 2. Cosine was found to be negative because of the location of theta. Plug in cosine, subtract your numerator, get this, and then you get 2 over 17. Divided by 2, that'll cancel this 2, leaving me with 1 over 17. Square root of 1 is a 1. Rationalize and you get to here. So this is the pretty answer. Any questions on the algebra or the pre-calc concept? Are you able to determine which signs to choose? Because it's important.
2 and 2 cancel.
Yes, because you're gonna flip it over, multiply by a half. The stuff I show is this right here will turn into this. Which gets you this. Excuse me.
Even on the 1 minus 15. 1 plus negative 15 over 7.
Yeah, 1 plus negative, so it's the same as
Yeah, so
1
that's-
minus. It's like adding debt is the same as losing money, right? Usually. All right. We'll leave tangent for you guys. Running out of time. Let me take roll in just a second. And if you have any questions, you're free to stay for a little bit.